In this video, I'd like to cover how we can describe motion and positions in both equations and also in pictures. So we're going to start off imagining that we have some object. And we're going to draw that. And that object is going to be sitting somewhere on a ruler, which we can call it like a number line, and we can mark out the ruler. 1, 2, 3, 4, 5, 6. So this particular object is in position 3, and we're going to want to describe this. So I'm going to call this the x-axis, and so I'm going to say that this represents a position of x equals 3. Now, if I wanted to plot this, make a picture, so I'll make a graph, what I would do, I'm going to be, and since I'm caring about motion, what I'm going to be doing is I'm going to be making a plot where I plot on the x-axis time, which I'll often just abbreviate as t. And on the y-axis, I'm going to be plotting position, which I'll refer to generally as x. Now notice that the motion for this object is really going to be left and right. So it's really going to go that way, or it's going to go the other way. But the position that I'm plotting the value on the y-axis, and you'll see why that is. So what we have now is we have 1, 2, 3, 4, 5, and this block is at position 3. So I'm going to put a little dot. Put a little dot right there. Okay. Now, over time, if this object is simply sitting here, okay. So imagine I take I'm going to get rid of the speed here. If it's just sitting there, then later on in time, it's going to be in the same spot. So this position will be the same, and so I have something like that. I have something like that. Something like that. So essentially I can represent a stationary object as an object that just travels essentially horizontally on this plot. It's really not moving anymore, but it's traveling in time. And so at later times we're seeing the same position. Now, how will this look different when we have the object move? So let's imagine this object moves. It's going to go forward, and we're going to find this object at later times. So let's say that this object happens to move 2 squares, or 2. Let's put some units in here. Let's call these meters. Okay. So it moves 2 meters every single second, and so 1 second later it's going to be at position 5, another second later it's going to be at position 7, and so on. So we can imagine this is at time t equals 0, at time t equals 1, we have the boxes here, and then at time t equals 2, the box is at position 7. So this is t equals 2. All right. So if I'm going to plot this, what I'm going to do is I'm going to plot it. I'm going to do this in red here. It starts in the same spot, and then if I mark out 1 second, 2 second, 3 second, 4 second, what I'm going to find is that 1 second later I'm at position 5. 2 seconds later I'm at position 7, and what I get is I also get a line, but I get a line that looks like that. All right. So notice one thing about these are both straight lines. This has a slope of 0. Slope equals 0. This one has a different slope. Let's do rise over run. So we'll just take 2 points here. The rise here looks like it's 2 meters. The run is 1 second. And so we get 2 meters per second. And so the slope actually has units of whatever units this is over the units of x. And we'll notice that this is the speed of the object. So the slope of this line gives you the speed of the object. And so here again, this one also is the speed, and it's actually 0 meters per second, and this is also the speed, but it happens to be going. This happens to be stationary. So one thing to notice here also is that if we had a curve, that if we plotted the position of an object versus time, and we had a curve that looked like this. All right, let me actually, sorry, did I do that in a slightly different color? Okay, so we have a curve that looks like this. All right, then we know that that object is moving faster than an object that, let's say, moves like this. Okay, the slope is lower on the green curve, it is higher on the blue curve, and so we can immediately see from the picture which things are moving faster, which things aren't. Now I'm going to end this with two questions. Okay, and again, so this is time and position. Okay, and the first question I'm going to ask is, what would a curve like this represent? What type of motion? Okay, that's number one. And number two, what would something that looks like this? Okay, I'm going to start there and do that. So not straight line motion. So think about those two things, and I'll start the next section explaining those two questions.